So, yeah, I'm Bogdan, and this is Mikhail. And today we're going to talk about our implementation of the command query responsibility segregation and plus event sourcing design pattern. We decided to use Qt for this, and yeah, before we start, just make a short presentation about our companies and ourselves. So, Mikhail?
Okay, hi from my side. I'm Michael Wagner. I'm CTO of the IPO plan. And this talk actually is a good example what good things can happen at Qt Dev Days, because we guys met at last Dev Days in Berlin and made contact and started to work together. So that's pretty cool. And yeah, we're doing factory planning and production optimization, and we write our own software to do that, and we sell that software as well. We created this IPO log software, which is heavily dependent on QML in 2D and 3D, and by our knowledge, it's one of the most complex QML-based applications based on Qt around. And yeah, as I told, we started working together with you guys last year, and I hand over to Bogdan.
Yeah. Okay. So I'm Bogdan Ogrean. I work as a senior software developer at Fortech for 4 or so years. And about Fortech, we're actually a software services provider from Romania, and we have some 15 years of experience at this point. And in the past years, actually in the past 5 years, we've been 4 times including in the Deloitte Fast 50 Central European top. That's always a good sign. And we're actually quite a big company in this domain for Romanian standards, and actually we have a really broad technology expertise. So yeah, if you think you need us, just you find us on web or on anything. Okay. So exactly, I don't know how many of you have experience with these design patterns. Has anyone worked or read about them before? Yeah, so there are a few hands. So,
not doing domain-driven design yet?
Yeah.
Nobody?
No?
Okay.
Basically, the command query responsibility segregation was first described by Greg Young a few years ago. And the main idea, which is the only thing we need to know about this at this point, is that it uses different models for writing and reading. They don't mix, they don't care about each other, and so on. If you want a more detailed description, you can access the one by Martin Fowler, which I find to be really nice. About event sourcing. The basic idea is you don't store the state in the application anymore, you just have the stream of events. And you build a state from that stream whenever you want. Martin Fowler, again, added a really nice description about this. Yeah, it also goes very well with domain-driven design. I've said that, I've seen that no one really has experience with that so far. What was our goal? Why we started this? First of all, these design patterns come from the services world, and that is not really such a C++ world. So most of the implementations were Java, and yeah, we had to try it to see how it goes. It started as a proof of concept, and yeah, we're curious. We just wanted to see how it goes, and it actually went pretty well. And why we chose to use Qt? The main reason was that the signal slot system fits perfectly with the events and the CQRS. Basically, you have you are signaled that something happened through an event, and you react to that. That's the main idea of the signal slot. So it's a perfect fit. And at some point, when it is stable and it's proven its reliability and that it's usable, we think about making it open source, maybe extend it or let other people use it. Okay, going next, we're going a little bit through the architecture. There's a lot of stuff going there, and We're actually going to talk about each one of them. How the presentation will go, we'll take one component, describe it a little bit, and show the most relevant code which implements it. At this point, don't pick on the code, it's just what is needed. It actually might not even compile, or no error checking, or no stuff like that. It's just the main idea. Okay, so first we'll start with the buses, with the event bus and the command bus. Actually, in our application, we use only one bus. After starting to implement it, it really didn't show that we need two buses. It's the same functionality. And we actually call it the message bus. And how it is implemented, it's actually a template. And for each event type, we are going to, actually for each message type, we are going to send on the bus. We have an instantiation. What's the API for the message bus? It's actually quite simple. We have two functions to register the message publisher. The message publisher, we're going to talk to describe it a little bit more in the next slides, is basically used to send the message. And then we have the subscribe function, which we use to receive the messages. What we do in these two functions, we basically do some error checking and then connect in the register message publisher, we connect the necessary signal from the given publisher to all the registered dispatchers, and in the subscribe, the other way around. All the signals from the registered publisher to the new dispatcher. And we store them for future calls. We also have, for convenience, the unregister and unsubscribe stuff. In our proof of concept, we actually don't use them, but it's nice to have them at some point. Yeah, this is all about the MessageBus API. We should go for the message publisher. Actually, this is the entire class. We don't really, we only need the signal from this. The main reason was that because we have the base class, the message class type, we actually needed each signal to be emitted from a separate object, from a different object. So whenever we need to emit something from one place, we actually we aggregate one of the message publisher in that class and use this. Yeah, that's all about this. It's fairly easy. Then the message dispatcher, it's a bit more complex. The idea behind it is that it has the slot, the dispatch message, which is called by when the signal is emitted from the publisher. And what's the main idea? We store a map inside with the type of the message we want to handle and the handler function. It's just the function stuff from the STL, nothing special. What we do, we first need to set it up, what we want to actually dispatch. And for each message we want to dispatch, we add the function. This is again a template function, template method, where we take the ID of the template instantiation of the type and associate the handler. And in the dispatch message, we basically get the type of the message, we get the handler, and we call it. And that's it. Yeah, don't pick on not error checking if we already have the handler. It's just a simplified code. Yeah. And this is all about the bus and getting the messages around. What we should go next is about the event storage. What's an event storage? As the name says, it stores events. It can be pretty much anything you think about. You can think about, I don't know, we currently have two implementations, an in-memory one, which is just a list of messages, or we also have a file one for storing on disk. We are also planning to write a database one, and yeah, if you have anything in mind, you can do it. Basically, what the event storage is, it implements this abstract class. So what's more important are the three methods. The store event, which actually stores the event. The replay event, which receives a filter specifying which events to replay. We have this method really useful in the read model, and which allows us to not replay everything we need and just what we not replay everything, just what we need. And the replay aggregate event, it's a convenience method to actually build aggregates. We'll talk about this concept a little bit later. And how they work, both of them, the replay events and the replay aggregate events, for each event stored, which passes the filter, we emit the signal with event replayed, and someone will have to listen to that. Okay, next one. We'll talk about the aggregate repository. This is a class which helps us build the aggregates for the system. How they are stored, there's nothing really about it. It's just a concept. And basically it offers two methods. One of them is straightforward, I've not added it, is the build aggregate, which replaces all the events and provides the result. And the save stuff, what we actually do when we save an aggregate, what we need to do, we get the unpublished events from the aggregate, then we store them, and then we publish them. Why it's not done in the single step? Because it might be the case that a single action on an aggregate generates more than one event, and then you might receive the first event before you've actually stored the second one. So it's not really something we want to do. And that's why we have the two loops and not one of them. And also as an optimization, so we don't replay everything, we can also create snapshots if it's required. So we have the aggregate, we store an intermediate state of it. Okay, this is pretty much everything about the framework we had to implement. As you can see, it's fairly small. And now we're going to give an example, sorry, about an application. We thought about it for the demo. And we're going to talk about the domain of the application. What exactly is the domain? It's just a concept. It's nothing physical or a piece of code. And it's unique for each part of the application. It just describes the concepts used, the events, the aggregates, and so on. So what application we've chosen? Well, actually, we chose to model the code repository domain. I think everyone is familiar with Git or any kind of repository. Yeah? And what we want to do is track the lines of code. Why we need this, besides the example, it's actually if you have an embedded soft application where you're really low on memory on the device, you might actually want to keep the lines of code really low, as there's a direct connection. And what we're going to do, we're actually not going to iterate over all the files in the repository and count the lines, but track the lines of code delta for each commit. So you know the commit has lines added, lines removed, so you have a plus minus delta there. Okay, sorry. So considering this domain, we define the aggregates, actually just one, the code repository at this point, which has all the logic for what we're going to do. We're going to have a command for this, like the commit command when we commit the code, and the domain events when the code has been committed. So the aggregate says that, okay, I received the commit, I handled it, we have everything in place. and the limit reached event when after the commit we have more than lines of code we expected. Okay, so first we'll go for the API. Basically, this is the API which we either link to a GUI or a service or anything else, which will send the commands. It's fairly simple. It's a small class. It's an LOC tracker, we've named it. And what we actually need to aggregate, as I've said before, a publisher, so the commit command publisher. In the constructor, we need to register it on the message bus. And then whenever we send the commit command, either from the UI or we add a Git hook to handle it, we just emit into the system the signal with the command. That goes on the message bus, and it's received as on the command bus, message bus, and as the diagram shows, it ends up in the command handler. What is a command handler? You probably guess it by the name. It handles the command. Fairly easy. And what we have to do here is instead aggregate a message dispatcher to receive the commands. We set the handling method for the specific command or message. And that's it. And subscribe it to the message bus. And whenever that message is emitted, is emitted from from anyone, we get the handle commit method gets called. What we do there, what the application needs to do. It checks the lines of code and so on. And it also actually instantiates the aggregates, gets them from the repository. About the aggregates, these are the building blocks of the domain. Are small pieces, are small elements which use which usually implement really small stuff. Like they're pretty similar to microservices. If you're familiar with them, I would say they're pretty dumb. They do one or two stuff and that's it, but they do it good. And how an aggregate looks like. We have the code repository aggregate. We have the publishers for the events. So when an action happens on the aggregate, it usually emits an event. And what we really need as methods are the constructor to set it up and committing the code and the action. How they are implemented. Again, the constructor fairly easy. We initialize the message publisher doesn't need to be initialized. Just register it on the message bus. And when we actually have the commit code action called, we add an event. Basically, the event and the publisher and the specific publisher. Add event is a method from the aggregate base class. It just fills the unpublished events list. It's nothing special about that. And we also have a check that if we reach the line limit, we also add the event, the limit reached event. And that's pretty much it, all about the logic here. With this, we're pretty done with the right side for the application. As you can see, it's really small, nothing big about it, and we also have a line of code tracker in place. And for the read model, we have the view there. We have two use cases here. Basically, we have a view already existing and we need to update it. So somewhere we have a line count which is displayed on, I don't know, we have in the main office like a big screen just showing lines of code. And what we have here, we have a message dispatcher to receive the event. And we initialized it. And whenever we receive that message, we handle it. And that's all we need to do to update an existing view. Just make sure you're registered to you're subscribed to the desired event. Okay, and if you want to create a new view, and here the event sourcing really shows its worth. So we need the storage, and we need, again, a dispatcher, which we are going to set up in the constructor. And we also have some initialized view to actually show the current state of the application. How we do that, we actually connect the event replayed signal from the storage to the dispatcher. Then we just replay the events. At this point, we send a filter just to send everything. You can add complex logic, whatever your choice is there. And yeah, it's really important that we use the direct connection. That means that all the events are handled immediately. We don't. It will block the UI thread if you have a lot of events, but yeah, anyway, you don't have anything to update, or you can optimize it. Yeah, that's another topic. And at the end, just disconnect it so you don't get weird stuff later. Okay, so this is pretty much all about the implementation, about actually a new application with a new framework. As you can see, it's not that much. And yeah, as a conclusion, let's go to the advantages of using this framework. One of the most important is that as a developer, you only need to have access to what you need. So if you're working on the write model, you don't really need to care anything about the read model. They have the events, and they can work with them. You just need to emit them when you think it's necessary. And also on the read side, you don't really care about the write model. Actually, in one of our older projects, because of optimization for the read model, they tried to make it more responsive and so on. They managed to half the performance on making some write operations in the application. So that was really not nice, because just optimizing for a view, you break the write side. And yeah, we don't want that anymore. Also, what's really important, if you think your existing application is not good, so you have it implemented in Java or Python or I don't know, it's easy to switch to a new application maybe in another language, but because you have the events, you can power it up in exactly the same state. What's also important, the unit tests are reduced to a minimum. As you can see, all the logic is implemented in the aggregates, which are fairly small and dumb. And if you have 10 lines of 10 lines is really long, so 5 lines of code in a method with no ifs and so on, or maybe just an if, it's not really worth writing unit tests anymore. As you can see, adding a new feature like adding a new view, it's fairly easy. You just write a small class, initialize the dispatcher, and then write the handlers and the stuff. Also, scalability. With the bus, it's fairly easy to add a lot of stuff, and you can make the bus distributed over several computers. And at that point, as long as you have a good system to distribute the events, it's no issue. And as I said, you can really have optimized read models that don't influence the write stuff. And yeah, unfortunately, this is not the holy grail, so we have some bad parts here. The system is really difficult to understand. We have a lot of small components which are not, it's not very clear how they're linked. You really need to have a different mindset to what you're used to, or actually what I've been used to. And it just looks weird if you see a diagram. It's just a cloud of small stuff which is not really interconnected. So, yep. And I'm actually done now, which is perfect in time with yeah. So, yeah, because of this, it's not also suited for simple systems. It's just an overkill for that. Yeah, so that's it. I don't know if you have any questions.
So what was the real-life problem that you were trying to solve by adding this proxy model to the event system?
It was more like a proof of concept. We wanted to see how it works, and we think to add it in some future applications, which are suited for this type of modeling.
So, but what's the potential problem in the central state management? You can also have the version migration.
Yeah.
And stuff like folder alerted.
Okay, I understand now. So it's fairly easy to do it even when it's still running the old one, and you can have them in parallel for a while. Okay, on the web stuff, it's fairly easy to do that, but considering a desktop application, which we're more focused on, this is something which is not that often encountered. So I don't know if this answers your questions or.
I could add, we're right in the process of extending our application to a multi-user distributed environment, and that's one part of looking into different concepts and new design patterns to implement and to help that. And yeah, it's a different mindset actually.
Yeah.
It seems like you could have implemented about 80% of this using abstract messages and events and using signals and slots directly. What does this give you that made you want to try this?
We wanted to try this, as Mikhail said, something more complex, and try it as for the future projects to see if it's a path we're going to. And it's easily extendable. Actually, the first thing was, as you said, pretty much everything only Qt and use signal slots and so on. Then we got some issues when dealing with multiple signals in one class or something like that, multiple events. So that's why we had to end. Yeah. So yeah, we're out of time. So thank you.